there is one other thing that can happen with these rational functions, and it happens when we have things that cancel out. So remember, we're always supposed to factor these and simplify them at the beginning. Now, when we do that, we could create a situation where we don't have an asymptote, but we have a hole in the graph, or another word for it is a discontinuity. Let me show you an example of this. So we're going to start out with number 9 here. We have x squared minus 16 over x minus 4. So we should always start by factoring and simplifying if we can. So the numerator can be factored. Hopefully you recognize that that's a difference of squares. So it's one of those that's going to factor into the plus minus. So we take the square root of both of those and we get x plus 4, x minus 4. Now notice that the x minus 4's cancel out. So our function is just y equals x plus 4, okay, which is a line, which is fantastic, okay? We are going to go to our y-intercept, and we have our slope, and it just looks like that. Except, remember, back here, we canceled this out, okay? Originally, that's an excluded value, okay? If you just looked at this problem at the beginning, you would say, oh, well, x cannot equal 4, okay? There'd be an asymptote there. Well, since it canceled out, it's not a full asymptote, but what it is there is a hole in the graph, and we need to actually show that. So what we're going to do is we're going to go to 4 on our graph, which is here. Let me get in the right color. Okay, here's 4. And then, so this line is just continuing, but then there's a hole in it, and it keeps going, okay? So when we do these, we need to identify where that hole is, but then we don't need to go back to this function. We can just graph the simplified version. Now, let me show you this on Desmos. Let me show you this too on Desmos real quick. Okay, I've graphed it here on Desmos. It's the exact same function we were just dealing with, x squared minus 16 over x minus 4. And you can see on Desmos, it does not look like there's a hole there anywhere. Desmos will not show you the hole unless you click on it and go to where the hole is, and then you have to be real careful and hold it there. But you do see that for undefined, there is a hole in the graph. But by just looking at the graph on Desmos, it doesn't make the hole obvious. So let's check out this other one. Again, the first thing that we want to do is factor that. So let's see. These are going to have opposite signs. We need them to multiply to 5 and add up to 4. So 5 and negative 1. And this is great because that cancels out. So our function is just y equals x minus 1. Okay, so we're going to go to negative 1. We're going to count our slope up 1 over 1. And this is what our graph is going to look like. But remember, we have a hole in it. Okay, this hole happens right there, that thing that canceled out. We have a hole at x equals negative 5. So what we need to do is go to our graph. We need to go to negative 5, 3, negative 5, come down here and just show that we have a hole there before we show the rest of our graph. Okay, so when you have a factor that cancels out, it's still an excluded value, but it's just not a full asymptote. It's just a hole in the graph. Okay, and so you may see those pop up now and again.